What's up, everyone? Welcome to today's stream. It's running a little bit later than it has been for the last few days. Wanted to give this time a try. It's Friday afternoon. Hopefully you guys are, you've gone through the work week. Hopefully you guys are getting ready for an epic weekend. And you want to hang out for the next hour, hour and a half, and I'll get you through the rest of your workday. So in today's video, we're going to be going through some of the stuff that we worked on yesterday. By the end of yesterday's stream, I'd finished the project, and then I'd started a new project, which was supposed to be like a 1 hour, 2 hour design project. I was creating a mechanical sculpture. Yeah, I've been thinking about it overnight and throughout the morning, and I actually have this project has grown in scope, as they tend to. It's almost impossible for me to start a project without it growing in scope and extending from I don't know. It always starts as oh, I'm going to get this done in 2 hours, and the next thing I know, it's like a whole week or maybe longer. But yeah, so that's what this is. That's what you see on the screen in front of you. This is the start of the project, and I haven't quite conceptualized where it's going yet, but I think we're going to go into a sketch on the whiteboard. We might have to do it on paper today because the sun's on the whiteboard and you might not be able to see it, but let's see if we can get anything. Yeah. It's not amazing. So let's do it on the desk here. So just bear with me while I set up the camera. Shouldn't take too long. It's this guy right here. And we're gonna get this lined up right over here maybe. Let's get this cable out of the way. So a lot of people have actually been asking me about my process recently and how I design these sculptures, and it's really hard for me to make that a simple answer. So the best way is to just show you the process from start to finish. And that's what this video is here. So let's see. We got this camera on, this camera off. This camera on, off. This one on, this one off. There we go. Perfect. And I'll get some paper to draw on. Beautiful. Okay, so basically, if you saw what I was working on yesterday, oh, this is right in my face. There we go. How's it going? Thanks for joining the stream today. But yeah, so let's pull out what we worked on yesterday. Which was this project. And this project, when you crank it, you can see the wave creates this wave motion that goes up and down. And we're actually kind of building on this principle, which is really just the way that it works, is this segment right here. So as it turns, that segment goes around the circle and it pulls the strings in a sine wave. So we're basically going to grab this mechanism right here and we're going to apply that to a new sculpture, which I'm actually really excited about. And the plan is to make it so it hangs on the wall. So where's my pen? Here's my pen right here. So the plan is to we're gonna make that circle. So that would be something like that is the circle, and then the string is gonna be on a string mount like this. This circle is gonna represent that gear. And then the string's gonna come out of that and go into this ring. And this is all just stuff that I've thought about. So if you're wondering where these ideas are coming from, it's just, this is the design in my head that's coming out. And you can see it's actually already on the screen. We'll go back to that once we're done here. I'm a little shaky because I just did a workout. I apologize for these shaky lines. But the string is gonna come out. We're gonna do 16 strings. So we're gonna have 1 point here. We'll just get those points lined up. 1 point there, 1 point there. Then get these parts right here. Then we'll get in between. So like I find it's pretty important to start with a sketch because like often what I have in my head is not quite the thing that's actually coming out when you start to put things in physical space. Even in a sketch, you're just like, oh, actually I didn't see that part. I didn't see that part quite right. So it's very important to get the sketch going first. That's at least in my process. Before I jump right into the CAD. Sometimes I jump right into the CAD and then I'm like, oh, I have no idea where this is going. Sometimes I do both at the same time. So there's no specific way that the process works. But so basically what I'm thinking is the strings are gonna come out of this ring and they're gonna go to some sort of bar. And I haven't decided yet if they're gonna be connected or not, because you could mount them on the wall separately and still get the same effect. And one person to look at is his Instagram handle is at Ruben Margolin, and this is the inspiration for this piece right here. His stuff is really awesome, so check it out if you've never seen it before. But the way it's gonna work is like this. The string is gonna come out of this disc right here. It's gonna go through a hole in this ring, and then it's gonna somehow get routed to this bar. And from this bar, there's gonna be pieces hanging, which are gonna look something like, I don't have an example for you. I'll just draw it. They're gonna look something like this. They look a little bit like, kind of like bullets or like bombs or acorns, I've heard. And they're gonna be hanging from these strings, and each one's gonna be hanging, it's gonna create this sine wave form. Let's see if I can draw it nicely. We're just gonna do a quick mock drawing. I need 16 of these, but it looks like we're not gonna get 16 in the drawing. It's just to get the idea. It's gonna create this sort of shape, hopefully. This is the wave, and this is a sine wave. So I don't know if you remember from math class, but a sine wave looks like this. And this is a shape that we can create with this turning of a circle. And this is actually exactly the output that these things are gonna look like. It might not be, it might not be that shape. I actually have no idea. This is one of the situations where I'm gonna be surprised, hopefully. So to get this shape from these circles, from this circle, the strings are gonna be coming out from here, and then they're gonna route somehow to get to here, right? And then I guess this one's gonna route somehow to here, for example, and this one's gonna route to here, and you're gonna repeat that all the way around. This one's gonna route to here. So obviously I did not make enough of these, but let's just see what happens if I make more. Something like that. I don't know how it's gonna work. But, okay, so the original plan was to do it like this. So this is gonna be the base plate. Hey Ryan, how's it going? I'm working on this kinetic sculpture that is based off of like, I'm actually not showing you here. I'll show you just like this. There you go. So as this turns right here, there's gonna be strings that are attached to this disc. They're gonna be routed through these holes right here. And as the string turns, as the string mount turns, it's gonna pull on the strings and release them, creating a wave. And it's similar to this right here. This is the sculpture that I built in yesterday's, this is the one that we finished yesterday in the stream. And as this turns, it creates this wave motion. So I'm now taking this exact same concept and I'm trying to put it linear so you can see the wave moving like this in front of you, and then the whole thing is gonna be mountable on the wall. So my original design idea, this is like something I mocked up really quickly at the end of yesterday's stream, was to have the crank on the side here, and then this is gonna be the middle, and all of these things right here that I was drawing are gonna be hanging from this bar through these holes. And I think I just changed my mind on how I wanna do this. The whole idea is that the crank is going to be on the side right here. And I want it to be so like when you're cranking it, you're not getting in the way of the actual output of the motion. So now I'm thinking that I want to do it. I'm going to switch back to drawing mode and we'll come back to this. What we'll do is this actually. We're going to put this here. Beautiful. So instead of doing it this way, like I have on the screen, I think what I want to do is have the mechanism and that crank, like, I'll draw it a lot smaller actually. Oh, this is frozen. Let's see if we can fix that. Beautiful. Okay. So I'm gonna have the mechanism and the crank on this end here, and maybe it's gonna be attached, it might not, but the bar is gonna be over here. And then the whole thing is going to route with strings to this. And I was trying to figure out the best way to route it. It could be cool. It could be cool if the whole thing routes through like something here. So all the strings are going to, maybe I can bring you guys, there you go. You can see a little bit better. So all the strings are going to come out through here. You're going to crank it from here. Yeah, and the strings are going to come like this, maybe. That's one way to do it. Hey, Sarah, this is actually not the clock. I got carried away with the end of yesterday's stream, and I want to get this project kind of figured out. It's based on what we worked on yesterday. It's just like a wall-mounted, like flat version. So I'm just trying to figure out like aesthetically how I want it to look first before we get into the engineering. It's funny, yeah. This does look like a clock, but it's actually not the clock. It's not. We're gonna get into that later. Maybe next week. This is supposed to be a quick project. So hopefully it'll be done by Monday. Hopefully it'll be done today even. Because we already have a lot of it done. So really at this point it's just trying to figure out how we want it to look aesthetically, and then from there we can basically just get it ready for print it out and see if it works. So what I'm thinking is let's zoom into this portion right here, because I think it could be cool to print like in place some guides for the strings. So if we have our ring here, and let's say we're gonna get all the strings to come out one end, like right here, like this. This piece is gonna maybe all be one piece. And that's gonna look something, and it's gonna have, so maybe this will be our gear right here. There's going to be a gear attached to that. There may be a gear attached to that just to get the crank far enough away from the ring here. There'll be a crank here. So just as a note when you're dealing with gears, when you have gears in a chain like this middle gear is basically redundant. It's really just for transferring power, and it just gives you that distance. But the real gear ratio is between this gear right here and this big gear right here. And I think we're going to do something like, this gear is 100 teeth. This gear maybe will be like 20 teeth. So we're gonna have this is gonna be a 5-to-1 ratio, or it's actually gonna be 1-to-5. So for every crank, 5-to-1. It's gonna take 5 cranks to make one full rotation of this gear. That's less important right now. It's more, we're just trying to figure out the aesthetics, but it's important to have this in here so when I'm thinking about the way that the chain's gonna look, we can get a better idea of that. And maybe, yeah. I'm actually thinking it could be cool to use like a belt drive here, a 3D printed belt drive. We'll get into that. This is all future thoughts, but this is kind of how it works for me. It all just comes out at once and then I have to like organize it all. Maybe we'll put it here, belt drive. And I can show you an example of a 3D printed belt drive that I made, which I'm probably just going to reuse if that's the case. That could be cool. Could be very cool. All right, let's just keep going. So the strings, there's going to be 16. So we're going to make those 16 nodes again where the strings might come out. And I was thinking there could be like a fin system. So like there's like 3D fins that would be printed in place. And so like the first one would be like this, maybe. And I'll give it double walls just so we know it's a wall and not just a line. And then the next one's gonna be like this. And then the next one's gonna be like this. And I guess this is all gonna attach, like, these are gonna be guiding from the ring here. So the string is gonna come out of these rings, and I'm gonna probably change the way this is all done. It might actually be printed into place on the base here. Not sure yet. Yeah, not sure yet. But it's gonna be these whatever we're calling them, ribs, are gonna be attached to these holes here. So the strings are gonna come out of this, through these holes, through these rib systems like right here, and they're gonna all come out here where they're gonna be fed into the bar, which is then gonna, you're gonna be dangling the whatever you're gonna be dangling from those things. I think this is how we're gonna go for now. I don't know honestly if I like this. It might be better if we just use like a pin system. So the string is not like following a line, it's like suspended. So yeah, so if the string is gonna come out like this, maybe there'll be like a pin here instead. So it'll be like you can see the string, it's gonna be like suspended off the base. That could be cool too. Let's see what that looks like. If we do like that, maybe they all come to like a straight line. I guess they're not gonna have to be like so far apart. What would it look like if it was coming from here? Maybe like down and across. This one would be like it's kind of confusing, I know, but it will make sense once we start getting into the CAD. Like these will have to almost have like doubles, like, because I don't want it wrapping around the ring. So it'll be like this, and then maybe it'll follow that line. So that would have 2 pins, and this one would be like that. These ones would have to be like, yeah, that could look really sick actually, if they all end up parallel somehow. And at some point, the strings coming out of the back are gonna have to go through either the top or the bottom, but we'll do it like that. It's kind of rough, but. And this one will do the same thing this way. So the way I think I'm gonna design this is I'm gonna do it all with a sketch on CAD, and then we can basically create the pins from there, and the pins are gonna be printed on the spot. So, okay, we got ourselves a concept. Let's see how we can make this happen. So like one of the biggest things is like this whole system right here has to be able to fit on anyone's printer. That's how I like constrain all of my designs. Most people's printers have a bed size of like 210 by 210 or bigger, but this is kind of the minimum that I design for. There are printers with a smaller bed size than that, but I don't know. You can't win them all, you know. And there's a certain point where there's a certain size limit that I like to go for. Like I don't like to make things that are small. It's just kind of my thing. So let's get into it. I'm going to I'm gonna pin. How do I pin these? I don't know. You know what? We're just gonna get into the CAD, and this will come clear very quickly. So let's pull this up. We can get this out of the way. We can bring this guy bigger again. Boom. All right. Let's get this out of the way. We may come back to that. There may be some more sketching down the road, but for now, what I'm going to do is I'm going to start by making a new part. And we start with a sketch. So let's just get some dimensions from the old part. So this ring, which we're going to use as a reference, is a diameter of 108. So that's what we're going to go with on the inside diameter. So let's make a circle. Diameter 108. Yeah, so my sketches they're not always like clean sketches, because at the end of the day we can get a lot cleaner on CAD. And so I don't spend too much time worrying about the cleanliness of my sketches. It's more just to get the idea and the concept and go from there. So I'm gonna make the ring first. And we're gonna choose arbitrary dimensions, and we can clean it all up later. But so the first thing I wanna do right now is I'm gonna make a sketch that's showing all of the different string routing positions, just to see how it looks before we get too deep into it. So let's take this line, let's make a circular sketch. We're gonna do, I think 16 could be a cool number for this. Maybe too much. It does get annoying routing those strings, but I think the more you have, the cooler it looks. Like the more interesting the effect is. And this could end up being something dangling. It actually could be something just like, it actually could be really cool to have like this, but in its linear form, hanging in a nice cool waveform. But we'll get there when we get there, I guess. For now, let's just worry about this. Again, I know I'm all over the place, but yeah, this is just my process, so nothing I can do about it. So we're gonna make 16 lines here. This is just to represent where the strings are coming out of. So let's do a linear sketch pattern of this entity. And we're gonna go on this line. Oh, actually that's not how this, let's do it again. So we're gonna be doing this entity, linear sketch pattern, and we're gonna go on the y-axis, 16, and we're gonna go this way, and our spacing between these are just where the strings are gonna come out, so the spacing doesn't need to be that big. Maybe we can do 2 millimeters. I don't know. Yeah, I guess they're all gonna come out separately. So instead of doing it that way, I'm actually gonna do it this way. I'm going to create, before this sketch, a feature with 16 holes in it, and that's where we're gonna route the strings to. So this we need to create, it's gonna be somewhere over here. So let's make a plane like this, built off of that. Flip the offset. It's gonna be like maybe like right here. So one thing to keep in mind, which I'm gonna draw a sketch for reference right now, is the size of a bed. So let's just draw a reference sketch to basically show the size of the bed. Boom. That is gonna be 210. And that's the size of a print bed, so we know how big we can make this thing, but while keeping within the normal parameters of someone's print. And it looks like it's getting dark. It's so bright in here, but I guess it's just the way the light's hitting. So let me know if you guys want me to set up a light to get some more brightness on this camera here, but this is what it's all about, what's on the screen. Okay. So this is actually important for me to keep in mind is I want to have a crank out here. But the crank module can actually be an add-on. I can print that separately as a part and like snap it into the main base. And we might have to do that. This might end up being like this big with the crank and where the strings are coming out. But for now, we'll put that there. Maybe I'm going to do a sketch, a reference. I'll add to this reference sketch actually. This is gonna have this is like the big gear. It's got a 100 millimeter pitch diameter. We're gonna have another gear here. Maybe we'll do the one with 45, and we can change these numbers after if we don't like them. These are just purely for reference right now. Thank you, Yashodeep. I'm a mechanical engineer by training. That's what I went to school for. So that's kind of where the base of my knowledge started, but a lot of this stuff I picked up along the way. School only gave me like a starting point, but what I always talk about with engineering is it actually gave me the ability to believe that I could learn things that I never thought that I'd ever be able to learn. So there was a point where I had no idea how to do any of this stuff, and I also didn't think that I was someone who could learn how to do it, and then I did. So yeah, if you're ever interested in doing this stuff yourself, just know that you can do it. It's just a matter of learning. Okay. So now I'm thinking it could be cool to have these strings come out on an angle right here. So if we're going back to this view, right now I have all the strings coming out straight, but it could be cool if they come out on a radius and they get distributed to the bar, to this bar like this, through a radius rather than all coming out of like a straight line here. Like it could be just like, that could look really nice. Let's try it. Let's try it and we'll go from there. So basically what I'm gonna do is instead of having this plane, okay, I'll first do it like this. Finish the sketch, we're gonna get rid of this plane, and on this plane, we're gonna sketch an arc. Might actually be better if my face, no, that's the wrong one. Try to get this right. If my face is down here, then you can see what I'm doing up here. You guys let me know what you prefer. What parts you want to see. But on this sketch, so we need an arc. And I want this arc right here to be concentric with this. We're gonna give it a dimension just to hold it in place, and maybe it can be like there. So that's all still gonna fit on a regular 3D printer bed, which is sweet. And that's gonna be, we'll go with 3.5 millimeters thick. That wasn't supposed to be a construction line. And then we're gonna cap the ends and we're gonna constrain them. I don't know exactly where. Maybe just to keep it simple, we'll make this vertical. No, actually, because I want the strings coming out to the side. I don't want it coming out down here. So let's just constrain it with some angles. We don't want you to be vertical. I want it to be like this even. Maybe we want this to be horizontal. This and this, we're gonna make collinear. And then we can give it a radius, or sorry, an angle that will constrain it in place. So if you're working with any parametric CAD software, constraints are important so it doesn't break down the road. And if you want to make changes like this, like see, like I made this too big, so I can just be like, okay, fine, I'm gonna turn this to 95. Is that gonna fit? No, that's too small. But it will be fine actually, because if this is rotated, it would still fit on a regular 3D printer bed. So we'll just keep going. We can worry about that later anyways, but that's why constraining these sketches is really important. So let's extrude that up and then we can draw some holes into it. And I don't know the best way to do this, honestly, to distribute 16 holes across this, but there's got to be a way to do it. What's up, Neptune? How you doing today, buddy? What's up? Oh my God. I'm gonna try to say your name. You gotta tell me if I'm saying it wrong. Tlotlisang? Lotlisang? I really apologize if I can't get that right. Plot. We're gonna go with plot. Thanks, Sarah. Okay, yeah. So I actually figured out the best way to do this. We go back to we're gonna create a plane. We're gonna create a plane at the mid point between these two faces. We're gonna sketch from here to there, and we'll just like say this is, I don't know, arbitrary dimension for now. Actually, no, we can do it this way. Okay, so we're just gonna leave that unconstrained. We're gonna constrain it after. Yeah, I tried. What do you want me to call you? T. All right, we'll call you T. I like it. Now we're gonna make it plain on the end of this line, at which point we can draw a circle. And we're gonna make those circles 2 millimeters is probably good. We're gonna cut the hole in this piece. We'll go up to next. Let's see if that gives us a hole. Nice clean hole. And now we can do a feature pattern, circular feature pattern around this point. It's not gonna let me do that. We're gonna make an axis first on, we need this plane and this plane. What's up, Mr. IMR? This is the straight, exactly, straight dingleberry, but I think it might end up being a straight double linkage because I love the way that looked. Yeah, this is the project we started yesterday. Okay, so we're making an axis right here, boom. I want to get this done today or like by Monday at the very latest because we have other projects to work on. And luckily most of this is already done. We're just trying to figure out like the best way to route the strings right now. Okay, so we're gonna go with this, whatever our thing was here, 16. 75 is too big. Boom. Best way to do it. Look at that. Okay, so what I really want to make sure though is, if we're gonna go back to this sketch, where is it? Here. I want to constrain this guy. And then we're going to constrain another guy to this side because I like when things are equal. 2.5. And then we can figure out what the distance, the angle is between these two. 62.09. Oh, I hate that dimension. This is like the I don't know, like the OCD in me. It's like it's a clean dimension here and a clean dimension here. It gives you a bad dimension here. So when I go here and I try to, what was it, 61.09? Okay, fine, we're just gonna go with 61. Oh, it's 62.09. All right, we're gonna go with 62. Screw it. I'm gonna get over it. I don't know yet what I'm doing. I'm kind of just like winging it at this point, and we're trying to figure it out as we go. But the plan right now is to, and you guys, please give me your input if you have ideas, because like we're still in the conceptual stage here, so that's the best part about this. But oh, wrong. I'm still figuring out my cameras here. Is it this one? It's this one. So I'm just trying to figure out how to route the strings from the ring. And like this is one thought, to do it this way. Another thought was to do it this way. But so this is what I'm thinking. This right here where the strings come out is going to be this semicircle. And then I'm going to route the strings somehow towards that semicircle. And then from here, from this semicircle, they're going to come out to, I don't know where the drawing went, to the bar like this here. So instead of this like straight part right here, it's just going to be a semicircle down here, and then they're going to go from there out, and we'll see how that looks. If you guys have any better ideas, let me know. Like, that's the fun part about this. So let's just see what it looks like if we route the string. So now we can go back to this sketch. Let's hide some of these planes because they're getting annoying. We can hide this reference sketch too because we don't need it right now. Hide this. We can edit this sketch. We don't need this anymore. So it's these strings that we're going to from these. This is where the string has to come out of this ring right here. And we're going to find ways to get it to go to this point here. And I'm thinking it's going to come like, could be cool if it comes around. Gotta figure out which one goes to where. I guess it's probably best if this string comes to here. Now that I'm thinking about it though, it's important the order that they come out and where they go, right? All right, we're gonna try it, and we're, you know, like worst comes to worst, it doesn't work, and we iterate, and that's just the way it goes. Okay, so this string right here, we're gonna work in straight lines right now and give it corners after, and then we're gonna worry about if that's gonna work. So it's gonna come like this, here, to like here. I'm actually on the wrong plane right now. I should be working on this plane. So let's just change that quickly. We're gonna change it to plane 2. Because that's coming out of the middle now. I just want it to look clean. That's really my only concern. And it would look cool if there's these like pins that are like coming around to each of these points. Let's just see what we get. Let's see if I can even tie this to this. Yeah, sweet. Oh no. That's weird. That didn't work. Pierce? It's good enough. No worries, Sarah. Thanks for tuning in. Yeah, today was a little bit of an off day from the normal time, but I think we're going to be going back to our previous times on Monday. We're going to figure that out. I want to know what works best for all of you guys. Okay, yeah. For now, let's just use these squares, and then we'll go from there. We can think about it a little bit more as we go. But yeah, thanks for tuning in, Sarah, and enjoy your weekend. And hopefully I'll see you on Monday. You can just call me Jay. But yeah, thank you. We're just gonna, yeah, keep doing this for now. If I want to go to the center of the hole, it actually is better that I'm going here. So we'll just do that. Boom. Horizontal. So I guess we gotta just keep going, working our way around. Actually, it's cool if these are coming straight out from the circle like that. I don't know. We'll worry about that after. Let me know what you guys think. So basically, the way I'm looking at it is each one of these corners here is going to be like a little pin that was printed into the base. And that will be where the string like curls around. The string, it's fishing line, but yeah, we'll keep calling it string. So Tobias, this circle is not going to be the one that's moving. It's going to be... Let me see if I can... It's going to be this that's moving inside the ring. And then the string is going to come from this through the ring. And then it's going to be routed out to where it's going. So right now, this ring is just a placeholder for this ring right here. Which this may end up being the part in the end. Okay, let's go from the top now. These have to... Yeah, this has to be this side. So... I don't know what it's going to do. Something like this, maybe. Something like this, maybe. And then to here. I don't love it, but we can clean it up after. It might look cool with parallel lines if everything's moving the same way. Might run out of space, it feels like. It's possible. It's gonna look interesting, that's for sure. If we make these two lines parallel. Like ultimately this is fishing lines, so they can be really close together. These actually might be too far apart even. What I'm wondering, hold on, we're gonna come back to this, but what I'm wondering is if I can, on this sketch, how do I do this? If I make, no, I need that still. I don't need this. If I make an arc between here and here. So this is like just a little trick so I can mess around with dimensions. That's kind of what I'm doing here. I'm gonna make this and this co-radial. Okay, I'm just gonna read this out. What about taking the line out of a hole at the center of the circle, then right angle to the arc, then down to the straight bar? Which center of the circle do you mean? Like out of the center here? Oh, like coming out like vertically. Kind of like what we had for the last project. Is that what you mean? So that would mean that they come like out here to here to here and then down a straight bar. Is that what you mean? I like that. This ring would have something coming out of the top like this. Yes. That'd be really clean too, and it's printable. This could be, huh. All right, we're doing a U-turn here, guys. We're going with Neptune's idea. That's a dope idea. I love that. Okay. Yeah, because then it can just come up, down. Okay, so anyways, we still got to do what we're doing, then we'll come back to doing that. So for this, what I'm doing is I'm just trying to constrain this pattern right here. Rather than it being an angle, I want to see if I can constrain it to this arc, which we might be able to, because then we can adjust the size of this arc. That's completely separate from what Neptune said. We're going to get to that after we do this. I just want to test a theory here. You'll see, it's going to actually come together really quickly. So it's this right here. We need to do, instead of doing we can do maybe a curve-driven pattern or sketch-driven pattern. I think it was actually the one. Sketch-driven pattern. The sketch is going to be this, but if we... Maybe it's a curve-driven pattern? Yeah. Yes. Equal spacing 16. Boom. So now I can do this. The reason why that's important is now I can do this. Let's get rid of this pattern. Don't need you anymore. So now I can, because this is constrained to this bar right here, I can change the dimension on this bar, this dimension, and that will change the spacing between the holes. And we can make it basically as small as we want. That's still legitimate. But I actually want to change the dimensions on the outside here. So we're going to go to this sketch. Nope, we need to go to this sketch. And one thing I'm going to do is this, just in case we want to change the dimensions again. If I make a straight line from here to here, oh my god, from here to here, and a straight line, construction line from here to here, that's constrained by this dimension. If I make these equal, now these are going to have equal dimensions, and now I only need to adjust this one dimension, and it will adjust both. So that'll bring both lines in a little bit. And I'm just trying to get it so the outer wall of this bar is thick enough. So that's pretty good right there. Okay, so yeah, let's save this before we screw up something. Wall mounted sine wave, WMSW, mechanism, base. That's what we're gonna call this for now. So forget it. We're gonna forget about this because I really like Neptune's idea, which is gonna be this instead. So let's get rid of this for now. It's gonna be this. We're gonna build the plane off of this right here. And maybe we'll make it like, I don't know, 50. And Neptune, you can tell me if this is what your idea was, but even if it wasn't, you inspired this idea by your suggestion. So that still counts. And maybe we'll make another ring here. How do I want to do this actually? Let's just try it like this first, and then we can go from there. Make another ring here, which is like maybe this size. Make it the same thickness, 3.5, and we'll make this ring. We'll go from the outer dimension. Sometimes I'm inconsistent with this. I don't know if it really matters. It depends on circumstance. And we're just gonna do it like this. I'm thinking it could be cool actually if this inner surface is curved like that, then the string is gonna come out of this ring through here. No, it's all gonna come out through the same point. So this actually has to be a smaller ring. This idea may not work actually. It may not work. Let's see. So the thought set is going to come up through this ring and it's all going to filter from here down to here. So now what I want to build is, we're going to go from, doesn't really matter which plane we use. We'll use this plane. Because this is the string is going to come up through this thing. Let's hide this body for now. It's going to look something like this. First, let's grab this face intersection curve. And we're actually going to grab this face here at the intersection curve. Boom. And we're going to draw a line from here to here. I want it to go like, maybe like this. And maybe like this. And let's see how that looks once it's printed. So what we're gotta do. What's up, Tomas? How you doing today, bud? This may not work. It's one thing when you're making straight lines on round surfaces, you kind of get something funny, but we gotta get rid of this and this. Okay. So we're gonna go with the same thickness, 3.5. We'll go from the mid plane here. And let's see what we get. So that's what that looks like. And then now we have to take that circular pattern it 16 times around the whole circle. And there we go. So this is actually like almost completely printable. There's these overhangs right here, but they shouldn't get in the way. And then I wonder if I can just take out this line here with a chamfer or something. Or like a fillet. Let's try a fillet here and see if we can take out the line. I'm doing great today. Yeah, so the height on this is gonna be dependent on, it's really just dependent on like this angle, because this angle can't be less than 45 degrees, but we can adjust it and figure it out. Let's see what it is. Let's see what it is right now. Right now it is 135 degrees, so 180 minus 135 is, come on, Jay. Oh my God, stress math. I'm just gonna do it on the calculator. 45 degrees. That's pretty lucky. So, okay, it has to be this height. So as it's gonna turn, it's gonna turn, it's gonna turn. The strings are gonna come out this ring right here. They're gonna travel maybe up here into this hole and out through the top of that. That's kind of what I'm thinking right now. And the question is this gonna be printable? And the answer is, I don't know. But I might be able to fix something by, this is kind of like messy modeling, but it just works sometimes. So what I want to do is basically just make a ring around the whole thing from the inside of this line. We intersection curve this, no. Yeah, intersection curve this. And then we're going to take this line here and we're gonna take this line and we're gonna take like, what do I want to do here? From here, and then this may not work, but Trial and error is our best friend sometimes if we don't know what we're doing. Yeah, exactly. Printing out the supports is a key design feature of all my designs. Sometimes you know what? No, I try to never like compromise on that. Sometimes you have to, but I try to never. Okay, so really I was just doing that to like create that, and it's actually not gonna help me because it creates these lines. All right, this should be printable. Let's just see. You know what? That's the best thing we can do. Let's just export it as an STL. Just this body. We're gonna import it into the slicer and see what it looks like when it prints. So it's just this top layer right here. Okay, so there's just this overhang right here, which looks like it shouldn't create any problems. Because like the gap is like pretty small. It's really the question is like these lines. Yeah, that actually should be completely fine. So this is like an important thing to do if you're designing for 3D printing and you don't want supports. Before you get too far in the design, it's always helpful to throw it into the slicer and see if you're gonna get the result you're looking for. And it looks like we will. So that's awesome. Okay, so actually one cool thing we can do here, we'll go back. It'd be cool, so I was thinking that the string is gonna come out through holes like here and then travel up these supports, but it could be cool to do something like this. Like have like a, how do I do this? Maybe do it like this. And we're going to adjust this, but I'm not going to constrain it for now, just for the sake of seeing how it's going to look. I cut it. Perfect. So this way, what's going to happen is the string's going to come up. It's going to be lifted off of this, and then it's going to go back in like here, and then it's going to come out through there. You may need to like extend this up more. And maybe we'll like flare it out a little bit. All right, let's see how this looks now with this here. Show, boom. So the string is gonna come up to here, and then from here it's gonna come down to here. And this is gonna be on a wall like this. Kind of like that. I love it. I love it. And then, yeah, let's throw this on. Actually, we can use this piece right here in this assembly that we already have going. Let's just hide this for now. We can hide this sketch for now. We're gonna hide this sketch for now. Where is it? Hide the sketch. No. It said hide. Go away. Go away, sketch. Does not want to leave. Oh, that's why. Okay. What the heck? Hide. Yes. And I think we're gonna get rid of this bar because we don't need it anymore because we're changing our idea. Get rid of that. Get rid of this. Get rid of all of this stuff. Don't need you. Don't need you. And we don't need you. Okay, so we got this. Insert components. We can figure out what's wrong later. Mechanism base. Where is it? Mechanism base. Okay. We're going to take that. We want that to mate there. Nice. We want this to be mated with this. Concentric. Nice. So obviously this is gonna have to come up, or this is gonna have to come down, but we'll worry about that after. Those are more of the engineering logistics. Right now we're doing just straight up. This is just some straight up, I'm losing my words, aesthetics. We're doing straight up aesthetics right now. This is just design work. And I guess we can mate this plane to the base plane, boom. So that's all constrained now. And then we can delete, oh my. Get rid of all of that red. Beautiful. There's like one thing, like when there's like broken things in SolidWorks, I just have to fix it right away. So that's why we're gonna do this now too. We can get rid of this broken sketch. We don't need it anymore. All right, so this is the question, is this gonna work? The string comes here, it comes out from here, it comes through here, and then it's gonna go into some secondary plate, which we're gonna make now, part, okay. Doesn't need to be very thick in this dimension. This dimension, we're gonna make it like, I don't know. I don't really know. This piece, I'm gonna make it specifically so it has to print on an angle, which I don't know how to draw. There we go. So this is the printer bed, 210 by 210. I don't know if I'm gonna live with this this constraint forever, because I do have a printer that's got a 300 by 300 bed, but for now, let's make this reference. So yeah, 250 by 250 length is actually, it's gonna fit on a bed if you orient it 45 degrees. So let's extrude that out. And we're probably gonna have to do more than 10, but it's all good. Now we're gonna make a sketch on here that will constrain our holes. Select midpoint, that is the midpoint of this line, boom. And then we're gonna have a gap from the edge of like 3.5, and we might need to make that bigger, like 4.5. Yeah, it's good enough for now. Boom. I think we made these holes 2 millimeters. You can change that dimension later. Probably gonna forget to do it, but it doesn't matter. I'll just have to reprint it. Classic move. Through all, boom. And then we need to linear pattern that along up to a reference. And we need, this is the reference. So that's my reference. And number, spacing and instance, no, up to a reference. This is my reference. I guess this is, gotta choose a direction. There we go, beautiful. And there's 16 holes. So that's gonna sit like this on the wall. So we need something that you can use to mount it. And for that, we're just gonna make something. For the time being, we can make these adjustments later as well. And I don't know how we're gonna mount it right now either, so we'll figure that out later as well. But for now, we can just extrude that out, give us a little bit of a surface that we can mount to the wall. I don't know, I have this theory that using hot glue to mount things to the wall might be the best option, because with hot glue, you can just use rubbing alcohol and it comes right off. I don't know what that does to drywall and paint though. I haven't tested it yet. So I'm gonna test it and hopefully my landlords don't notice. Let's call this WMSW_wall bar. So installing it on the wall, you're gonna have to space out the strings once it's on the wall, and I'm gonna hopefully come up with a better method for that than what we were doing the last time, but I probably won't, realistically. Okay, cool. So let's just put this into the sketch, or into the assembly for now. Insert components, wall bar. It's gonna go here or something. This is gonna be made to here. X, that's my mate shortcut key. And I don't know where it's gonna go right now, so I'll just leave it there for now. And just for the sake of like, let's just make a wall here. Just for the sake of understanding how this is all gonna look and come together, we'll just make it some arbitrary size. A 500 by 500. And some arbitrary thickness of 10 millimeters. There's our drywall, WMSW wall section. You can even give it like a pattern. Appearance of brick. Fire brick. Face. That doesn't even look like brick right now. I don't know if it's because I don't have real view turned on. Yeah. There we go. That's awesome. Yeah, you can get some pretty big stuff if you're using a 300 by 300 millimeter bed. I'm still trying to figure out what my business model for everything is here, and that's why right now everything is I make it so anyone can print it, but things might change down the road. I have some big ideas of stuff that's coming in the future. So yeah, we may take out that constraint and start printing on the big bed. Yeah, shout out to Lulzbot. They sent me the printer, and I didn't have a printer bigger than my Prusa, which is like I think it's like 210 by like 235 or something strange like that. Or maybe it's 250 across. But yeah, having that big printer has been so clutch. Okay, let's put the wall in here. We're gonna turn off real view because it's gonna slow everything down. Boom. But yeah, so that's everything on the wall. And you know what? Let's give this, instead of a brick, because it's so dark, let's give this a better appearance. Take out appearance. Peace out, fire brick. Here for a good time, not a long time. Let's go with like a bright. We're just gonna go with like a bright color. A nice luminous white. Nice luminous white wall. There we go. Okay, cool. I'll move it over there. So there's our mechanism on a wall. Beautiful. If I had a laser cutter, I'd probably laser cut a panel for this whole thing to mount on, and then you can mount that onto the wall. That'd be pretty dope. But for now, we're just gonna do it like this. So, coming back to this piece, let's figure out how this piece is gonna work. Because if we're going with this string tower system, which I think we're going to go with, I like how it looks. I think this is gonna be the way to go. It solves the problem here where these gears are gonna be coming out of the side here. Let's see how long this piece is right now. Or maybe we're gonna do this. We're gonna like turn, I'm actually gonna do it like this. I'm gonna make a couple separate circles. Let's give it some random dimension for now, 65. And constrain it horizontally here. Boom. And what else do you want from me? Oh, distance, of course. And we're gonna go with this arbitrary distance of 75. I find when picking dimensions, it's best to just make quick decisions. That's actually probably like a really smart thing to have, eh? When I solder, it's just like smoke in my face. How do you have it hooked up to like a computer fan? I just want to make sure I was going the right way here. This has to go this way. Okay. And then maybe we're gonna have one more coming out. This is a little bit thick. It's a little thicker than it needs to be. I'm doing this the wrong way, I think. What I should do is it like this. We're gonna do it like this. Sketch. We're gonna throw in some construction dimensions for our gears. That's got a 100 pitch diameter. I think we're gonna use a 45er here. Also, where do you put them? Do you put them on Thingiverse? Is that what you designed for? Or do you sell them? Okay, now we can draw these circles. Boom. Draw this circle. Boom. Make this less thick. Nice. And then what? It just vents out into, like, I guess the carbon filter catches and like vents everything. Just vents out into the world. I actually want to make something for my printers because I find when I have them all running and I'm sitting in here for too long, I get like a really scratchy throat. So maybe that's the way to do it though, is with just a straight up carbon filter. What happened? There we go. So maybe we can just use, yeah, I like that. We're gonna use consistent dimensions off of each of these gears. Boom, 12.5, boom. And I'm actually going to do this differently as well. I'm going to use gear dimensions. So for gears, we have 100 pitch diameter plus a 45 millimeter pitch diameter. Now we divide that by 2, and then we're going to add some clearance. So that's 72.5, and then I want to add like maybe 0.25 millimeters clearance. That's better. And we're going to do the same for this one here. Yeah, I respect that, man. I respect selling your work online. I personally also sell my stuff, so like obviously I have a bias, but I think people expect a lot for free these days, and I don't know how I feel about that. Especially like a lot of people are like downloading stuff for free, printing it, like posting it on their Instagrams, building this like huge Instagram following. And the creator gets lost. But again, I'm biased. Let's see how this looks. And you know what? To make this all easier to adjust in the future, we're going to use this old trick of construction lines. And these construction lines are all going to be equal. So if I want to make it less tick down the road, I only got to switch one dimension. Boom. So I can just do this, make this like 10, for example. It makes the other circle is smaller. And then I'm debating if I just leave them. Yeah, it's going to be unhappy, but we're going to fix it. Selected contours. Boom, 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 boom. Get rid of this. And now, if I pull this down, let's see what we get. Oh, something's not happy. Oh, it's so not happy. So it's saying cannot find face or plane. That's because I guess this is a new object. So what I have to do is just redefine everything. Thank you, Solidworks, for just not figuring it out. I appreciate it. There we go. This we can delete. And this we can, what is this? What is this? Cannot find face or plane. Same deal. Boom. Okay, that solves that problem. And then we need to make one for here as well. What's that? We'll worry about that after. We'll worry about that after as well. So let's get rid of these. I believe this should fit on a 210 by 210 bed. Let's see. Do one of these random circle, make these equal, make them 210. Oh, see how much space you get? But yeah. So if that's tilted like that, you can even still get the arch down here, which is great. And that'll fit on a bed, which is all I can ask for right now. Cool. Okay, so let's just let's finish this. We might as well finish the mechanical components today, and then Monday we can finish the rest of it. So what we need to do is this. I'd like to know what the distance is there. 7.5. So we're just going to use the same one. Constraint to the center of this. Do this like this. This is probably not the best way to do it, but I don't know. Sometimes you gotta just do what's working right now. Up to surface, boom. Now we're gonna add a flange here. And we're gonna make it the same size as this one. And we're gonna make it the same height as this one. Boom. And then we can put a shaft here. And then we can get the gears in. And then we're gonna call it a day because it's Friday. Yes. Who's got any big plans this weekend? I hope you all do. Gonna give it some arbitrary height. We'll figure that out later. And we'll figure out everything else later. Let's see how this looks here. Interesting. Something's not happy. It's because of this one face change. It's cool. It could actually be interesting to have this piece also as a separate, its own piece. So it would be like, you got wall, and then you got this is a one section here, and then you got this is another section here, and then this is another section here. And this actually should work well. I don't know, was it yeah, I don't know, Neptune, and like, I hope you don't take this personally. I don't know if we're gonna keep this. I don't know how I feel about it right now. I don't know if I'd prefer this or some sort of intricate method for like moving the strings around, or maybe even some combo of these two different things. But we're gonna sit on that over the weekend. For now, let's just finish the engineering, some of the engineering stuff, which is we need to get a gear in here that is 200, that is 20 teeth. So let's grab that from my gear library. I've been using M1. Boom. And we need 20 teeth. Let's copy it into WMSW underscore. Get rid of this file extension. Get rid of this. Break the link. Get rid of that link. Make a hole here. 9.4. And then I believe this is going to be attached to the crank. So we're going to grab a crank and we're going to attach this through all. Boom. And yeah, that looks good. So let's grab a crank now. I can't remember if I grabbed one already. So let's see. Take this. There's a crank here. Is this the wall mounted sine wave? Is that, yeah, WMSW. Okay, let's open this. And we are going to throw the gear on the end of this. So for this, let me just make sure it's not attached to anything here. The crank is not here right now. Okay, cool. So actually, now that I'm even thinking about it, this might need to be bigger. It depends. It depends on what we're hanging from it. We'll figure that out later too. Let's just finish the engineering. I keep going back and forth. I'll go through like at least 4 cycles of I hate this, I love it, I hate this, I love it, and then eventually we'll settle on something that works well. But yeah. So let's get that. Go back to this crank. We're gonna get rid of this and this and even this. We don't need this either. Get rid of these sketches. Boom, boom. I don't know what this is. Now we don't need either. Don't need that either. And we don't need that. So this, we're gonna put a hole in it. Make that 9.4 as well. That gives me 0.4 of clearance on all sides around every hole, and that seems to work for everyone's printers, at least as far as I've heard. This will go through all. I'm gonna go this way. And then we're gonna pull that gear in, insert, part, 20 tooth gear, where are you? Right here, check. And then we can get it lined up in the right position. This is annoying. I'm gonna use like a really messy way of fixing this problem, but we're just gonna make this gear bigger. We're gonna have to make it bigger anyways. 10, yeah, that's good enough. Why did it do that? That's why. Just need that, boom, okay. So now when we pull it in, we should have a face to work with here. Insert part. Do that again. Boom. That goes to there. Boom. And then we can combine the two, and look at that, it's perfect size. Combine that with that. Love it. So now we can pull that into our design here. And close this, we don't need this right now. Insert, oh, something's super broken now. What is your problem? Let's just delete the broken parts. We'll come back to that. Oh, I know what it is. This. Yes. It's our wall representation. Okay, now we can bring the crank in. Crank. It's got a weird name, but that we're gonna mate to this shaft. We're gonna make this here to this, and now we can make this a little bit shorter. We're gonna do that with this move face command. Let's go with that this way. Boom. Let's see how that looks. Sweet, looks pretty good. And if you're cranking it, there's a good amount of space there. Is there clearance? Maybe we'll make a little bit more clearance. And we're just gonna change that dimension we just made. And it will give us an extra couple millimeters, so we're only moving 3 instead, boom. Okay, so now we need to figure out how much taller this shaft needs to be. And that needs to be an extra 6.33. I hate that 0.33. Let's get rid of that 0.33. I think that's coming from this gear. It is. So we're just gonna do this. 3. Beautiful. Okay, so now we can figure out, I think that's 6 millimeters, 8 millimeters. We need to extend this shaft out. 18.2. Because I want a little bit of clearance at the top. And then we can just top that off with a little one of these things. And the way I do that is sketch, convert entities, extrude with this, and I extrude 0.75. And then convert entities, extrude with a draft the other way, and then top it off. Sketch, and boom. Beautiful. So that part's basically done for now. It's not aesthetically done, but it's done functionally. Mostly. We have to find a way to like attach this to the wall and stuff. It may be as simple as just like a couple screw holes in the bottom of the base here. Maybe one here, like one here, I don't know, one there, I don't know. I don't know what the best way to mount things to the wall is. I've been using command strips for everything, like the ones that are Velcro, but they don't always work with 3D printed parts, so we may have to just screw it in, which is fine. But yeah, so just for fun, I'm going to put the gear ratios in here. So let's get those gears. It's actually this, we need this, and we need this. So we're gonna line up the teeth. Those look pretty good, good enough at least. Oh, those are already done, sweet. So we're just gonna do these two. So it looks like there's actually a little too much clearance here. We're gonna fix that after, but for now, I'm actually a little confused why there's so much clearance there. But let's just get the gear done first, and then we can test our theory that this middle gear is redundant. Mechanical mate gear. This has 20. This is 45. Check. And let's see. Dope. So based on this ratio, this is a 20-tooth gear right here. This is a 100-tooth gear right here. So it should mean, let's just get this lined up in a way that we can count. Okay, so just keep an eye on this. It should take me 5 rotations of the crank to get this to spin all the way around. So let's see if that works. 1, 2, 3, 4, 5. Perfect. So this middle gear is actually redundant. It's purely just to get this distance, and I like the way it looks. It's kind of an interesting look. It's kind of like a sideways snowman. And that's what it's going to look like inside there. And then the strings are going to come out through here, down through here. They're going to be dangling little like danglies or just something at the bottom here. And yeah, that's the design as it stands right now. This may be attached to this. This may be its own separate piece that you attach after. Or it could just be straight up attached to this. I'm not sure yet. I haven't decided what we're going to do with that. We'll figure it out. Cool. Yeah, guys. So this 1 hour project yesterday is obviously turned into, like today we've already worked on it for an hour and a half. We're probably going to finish it on Monday, have it printed Tuesday. I don't know, put it together. Maybe we'll do a live stream in front of a wall and see if it actually works. I don't know, but thank you guys so much for joining me today. This has been fun. I hope you guys have a great weekend, and I hope you guys are ready to do some more engineering on Monday. So until then, peace out.